So my name is Sérgio Silva. I work for Cisco in the advanced threat management side of things, and I work for an organization called OpenDNS. Just a quick vote from you guys. Has anyone ever heard of OpenDNS? Have you guys ever used it at home? So you know what it does, or shall I just tell everyone what it does? So one of the main things that the Advanced Threat Unit is defending against a lot of the types of malware that we have out there. So malware coming from different points of the internet, where it's basically where the actual actor acts in plain sight. So the caveat for any sort of attacker is that he's going to have to host his infrastructure on the internet, and that means he has to use IP addresses. He has to use the hosting platforms on the internet, which makes it really hard for them to hide themselves. So they obviously use different tactics. So a big problem that we have today is, and we speak a lot about this, is ransomware. Does everyone know about ransomware? Has anyone been affected by ransomware? I'm sure if you were, you wouldn't even tell me, because obviously it's the most embarrassing thing, but it's a very clever tactics of what they use in order to get the stuff onto your machine. So we see these problems, and essentially ransomware is a mechanism that people use to drop malware onto your device, and it's much easier to drop ransomware onto your device than a full-blown payload of Salty or any sort of variant. And the reason behind that is because all I need to do is to drop that payload onto your machine and then encrypt your data, and then make sure that there's a page that comes up that actually tells you how much money you want to hold that data for. Now, as time's going by, we are seeing that there is more intrusive tactics. They're not just encrypting the data that's on the machine, but then they go searching for any sort of network shares, and that means your network then becomes compromised because they go looking for servers and they go and encrypt those servers. Now, the latest tactic is not looking just for specific data that they want to encrypt, but they actually want to go after the whole hard drives. So they encrypt the full hard drive, and that means that you can't do anything, especially if you haven't backed up, and you basically are held to pay for that data that you hold secure. So there's a lot of people that are being affected by it. Some people will admit that they've been compromised. And a lot of meetings that I have where we go in and we start using our solution to pick up on these type of compromises, the first question I ask after a couple of weeks, we've seen what's going on, is, have you previously been hit by ransomware? And usually the body language is no, which automatically I know something's gone wrong, right? But they don't have to tell me, I already know, because of what I see happening and the type of requests that people are making using DNX as the actual exploit, the command and control back out to the internet, to the malicious domains. So if you guys have been around as long as I have, and I'm probably giving my age away, back in the days when we used to have things like Blaster, does anyone know what Blaster is? Oh, this is bad. I'm really showing my age. So Blaster, you could basically write an ACL and you could basically limit the extent of the attack. So when we go back in time and we look at how the attacks are becoming more predominant, it's also the number of funding that they have behind them. So the funding is basically run like a business. So if I'm a bad guy and I'm part of a ransomware or a malware distribution organization, I'm going to run it like a business where I'm going to give you SLAs. I'm going to ask for the malware to be tweaked, because not all malware is going to get onto the device and do what it needs to do. So they can easily call up the guys and say, listen, malware is not working, can you try a different tactic? And they'll pay for that service. So call it malware as a service. And there's a lot of money there, and that's why they're doing it, right? So our job is to obviously try and lock that down, but as you can imagine, the analytics for us is not always in our favor, right? So when we take into perspective how DNS works, does everyone know what DNS is? I'm sure you all do. So DNS is critical to the infrastructure. If I decided to block DNS at the gateway here, how many people come running to us? All of you would, because you could no longer get to your sites or to any sort of domains that you're trying to call out to. It's critical to the infrastructure. Now that criticality is where the attacker is fundamentally trying to take advantage of, right? So in a lot of cases like we see here, these are real statistics, they're not marketing. This is what we see out in the real world, because we've got a lot of intelligence that we pull on. And essentially what we're telling you is that where you think you are behind a proxy or behind SSL, that you are secure, you're not. okay? Because if I'm using DNS to do callouts to the command and control infrastructure that I own to go and infect your machine further, or to try a different payload that will infect your machine so I can own it, this is what I'm using. I'm using command and control via DNS. Oh, we're telling you right there, 15% of that bypasses your proxies, and a lot of times the proxy is the one who's doing the DNS resolution. When they start pointing the DNS resolution to us, we actually start seeing that a lot of the stuff that they haven't seen, we start seeing because we are actually blocking that. Okay? 91% of that data is easily bypassed because DNS is doing callbacks, and I'll give you a great example. I had a customer based in the Nordics where we pointed the DNS to us on an afternoon, about 3 o'clock in the afternoon, and when I got to the airport, they started calling me saying, please, can we put a block in place? Because what they wanted to do was monitor at first and then put a block at a later stage. But they changed their minds very rapidly because they started to see what we were seeing, right? So what was happening is DNS, they were doing 50,000 requests every 2 hours out to command and control infrastructure that already had been taken down by the NSA 2 years prior. Now what that tells you is that they had a vast number of endpoints in their network that were already infected by that compromise, and were still doing callouts trying to find that command and control infrastructure. Now, you as a network engineer or an engineer that's trying to figure out what this problem is, you're not going to figure it out because you're going, it's DNS. It's a lot of DNS, but I can't stop it, so I'm going to just have to allow and live with it. It was until then that we were telling what they were trying to do with the DNS that they started to understand what those 50,000 requests were doing every 2 hours, so we started blocking it. So they had a lot of infected devices which they didn't know they had prior to that. So does anyone know how the kill chain works? So in the easiest possible method, I'm an attacker. I'm going to create a lot of domains. I'm going to create an exploit kit, and I'll run that exploit kit a couple of days before the attack, the real attack, and I'm going to find out how many users can I get infected. And I do that by saying, I'm going to disable your proxy on your machine, and I'm going to start doing callbacks to Google. Can I get back to Google? Can I get back to one of my low-end domains that are pretty anonymous? And then I'll say, okay, I'm good to go, and then I'll run the campaign. Now, when I'm running that campaign, it can be run as an email. A lot of guys out there have got those phishing emails. I'm sure you guys have seen it. It's that click of a button that makes that DNS request that then sends you to the phishing site, and you might put in your details, you might not, but that's where we start seeing things. So we will block at that DNS layer because we are blocking that, hello, where am I going? No, you can't go there. Or in the worst case scenario, you get to go there and you get an exploit kit being dropped, like I said, that tester, and then I'll start dropping malicious, I'll start calling out to my malicious infrastructure, which I own, and I'll start dropping ransomware payloads as an example. I'm using ransomware because that's the flavor of the year, all right? And then obviously, you then held at ransom for an encryption key to unlock your data. Now, one of the scariest things that, well, it can be seen in two ways. It's a very exciting thing. It can be a very scary thing. The exciting thing is Tesla Crypt just released all the keys, so everyone can have their data back. The bad news is, what have they got planned that's coming that we don't know about? That's what we as security analysts need to be worried about. So today, just to reinforce how important DNS is, those are the number of different types of exploits that we have out there. I'm sure you've seen a lot of them. Angler, obviously Locky is a big one, Tesla Crypt, etc. Primarily they're using DNS, and Locky has been clever in some instances where they start using IP. So instead of calling out to a DNS infrastructure, they call out to an IP so that it avoids that sort of mechanism, right? But that obviously changes because they're coming out with new type of ransomware. They don't need to do any call-outs. It just does it all there and then, and it's the only thing you're going to actually go to the domain for is going to be for the payment. But that's obviously very hard to try and get onto the machines, but they're working on it, just like any other business. So what does OpenDNS do? Has anyone had a block page here from OpenDNS in the last 24 hours? No? So you haven't even noticed it. So the good thing is you probably weren't trying to get to any interesting domains. The other thing is obviously that we're transparently enforcing protection from a DNS layer, and we're doing that via what we do today. The reason why we get to see what we see is basically because the more people that use our product, like everyone uses Google, you can use OpenDNS, except that OpenDNS can provide a security layer over that. So we market 80 billion requests a day. We actually are peaking at about 95 billion requests a day. We see over 160 countries that are using our product. We have about 65 million live users. We're actually looking more like 75 million, really, and over 15. Whoa. Let me put that up. And about 15,000 enterprise customers and growing because of the spotlight that we've got from being acquired by Cisco. Now, looks like a pretty picture. Who works in service provider here? Anyone? So from a service provider perspective, we've kind of drawn what a service provider would look like in different tiers, because you get different levels of service provider, and obviously different levels of service provider sees more picture. So the more densely populated type of areas is where you've got your tier 1 service providers like Portugal Telecom, BT, and all those type of providers. And as you move out, you start to see the more low-end service providers. And we can actually give you a picture of what we see from a DNS perspective, from what we see against our analytics and the way we build that picture against that data set. We have solutions that do a couple of things. The first solution is obviously an enforcement point, because everyone's clever and everyone will know how to change their DNS settings. So that means at the end of the day, if someone changes their DNS settings to Google, then we're not enforcing DNS to go to us. So what we do is we've got a couple of solutions that enforce that the DNS will always go to us, whether it's an agent that runs on the endpoint, or we're actually enforcing it on the network, like we've done here, where the access list says you can only resolve to us, and therefore you can do whatever you want in your machine. We'll always point the DNS to us, okay? Investigate is essentially, we call it investigate because it's quite interesting, because it's all about our intelligence. Everything we know from a DNS resolution perspective, all the intelligence we have on IP, where the IP is hosted on the ASN on the network, how the routing works between one host to another, and we can build a pretty good picture and an understanding of what's going on out there, plus payloads, plus all the analytics and the algorithms that we run with machine learning to understand that an attack is what it says it is, all right? So a lot of times incident responders find that that tool is very valuable to them, because when they're dealing with an incident, instead of jumping between different services to try and get the picture of what's actually happening on their network, they only need one tool, which we provide all that information to them. So it reduces the impact level of the time they spend trying to lock it down. And real world examples are there service providers out there that have SOC environments that I've demonstrated the tool to them, where what I did in 4 clicks, they were trying to do in 4 hours. When you're doing an incident response, 4 hours is a long time to spend trying to nail down very specific information. So this is how it basically works. Enforcement side of things, we are an any cost sort of architecture. What that means is we use BGP any cost to route to the closest data center. So when you're resolving DNS, we will look at it from, you only need 2 IPs to resolve to the primary and a secondary, and you always point to those 2 IPs wherever you are in the world, and we'll resolve you to the closest data center to make it very quick and very accurate. And obviously from an investigate perspective, it's understanding that you can pull on APIs, so you can go and code some scripts there to pull out what do we know about a domain, what is the threat vectors for that domain, what are the other domains that he owns or she owns, and we can give you predictively what they will use in future with other domains that they've got in their back pocket, right? So that we can pull from an API perspective. You can use the APIs to also do it on the enforcement side, where you can go and mass deploy, change rules, and understand your own users' personal behavior, right? So just so everything I've told you is put into real context and you can understand how we put that picture together, I'm going to use Lockheed as an example. So patient 0, that's where it all begins. There is obviously a whole bunch of things they look at when they're trying to do an attack on an organization or a specific group of people or whatever the case may be. They want to understand that whatever they're going to do, they're going to try and get as many victims as possible. And they don't care where you come from or what you hold. It's about owning you, right? When you look at the other side of the coin, you need to understand how they use and different tactics they use. Whether it's reconnaissance around, can I start, sending sort of logging or attacks against your firewall to see what ports are open. So I'm doing port scans. I'm understanding, what your behaviors is. So it's building a picture of how that's done. Then they're going to obviously create the infrastructure, and they use different tactics to do this. Specific tactics are things like DGAs. We call that domain-generated algorithms. So anyone who's registered a domain here understands that when you go create a domain, it's not a 5-minute job, unless you're creating one that you don't really care about. So time is against them, so they want to create as many domains as possible, and there should be no restrictions, because they're never going to actually use those domains to host anything apart from a domain that's going to host specific malware. So you're never going to type that domain in. So those domains are generated in such a way that they don't really human readable. All right, and I'll show you some examples of that. Obviously, from the intel we have, they're going to be hosting their infrastructure somewhere. They're going to have a bunch of IPs that they're using, and they're obviously going to change those IPs by using things called fast-flux methods, which is basically taking the IPs that they have in the back pocket, and they'll rotate the IPs every 10 minutes. They might do it every day. They might do it every day 4 or 5 times a day, which means that from a global scale, if you don't have a full picture of what's going on out there, they just look like they're popping up in different parts of the world, and you wouldn't know any different, right? Because you're going to that domain, you're getting locked down by what they're putting onto your device, and you basically owned. So, feeling lucky. We all know what ransomware is. It basically takes data on your device, it locks it, encrypts it, and then it gets you to pay for the actual data. And it's always done in bitcoins, because bitcoins are very valuable now. Actually, here's an interesting point. The creator of Locky, when he first wrote the actual code for it, what he was trying to do is look for bitcoins. Once he found the Bitcoin folder, he would encrypt the Bitcoin folder and then hold the ransom against you. Okay? He obviously saw the value of data, so he started going, oh, hold on a second, I'm going to scan for other stuff, and just randomly start encrypting and hold everything at ransom, because there's nothing there from a Bitcoin perspective, so I'm just going to hold your data because I've already got your machine. So that's how it all started, and obviously there's different mechanisms. One of the infection mechanisms is to obviously send you an email attachment where you've got a JS pneumocode or a JavaScript extension to that, and you basically download a Trojan, and it runs a whole bunch of malware and executables that can start owning your machine. You then start seeing that encoded ransom payload in a form of a data file, and before you know it, it's run. And that's how simple it is. So from an intelligence perspective, you can see that we've got a domain there, malware install.wang. It's very self-explanatory, isn't it? I mean, why would anyone want to go to a domain that tells them there's going to be malware distributed on that? Well, the key thing is that's the domain you get sent to without knowing, because once you've gone to the exploits, you've got it done, it then starts calling out, that's who it calls out to. And it's obviously got Locky as the actual payload that it drops into your machine. And then you basically got a number of name servers that they're obviously using, and you can see that the first time that anyone saw it outside from us was back on the 1st of September, right? Now this is one of the domains called Ransomware Tracker. You guys can all use it, but this is where I'm getting the information from. But what I'm going to compare it is with what we saw. So when you run the intelligence on us via the console, you'll get this sort of output, right? The first thing you'll see is, when did we detect it? 30th of August. So we saw it a couple of days before everyone else saw it. Okay? So that just shows you the power of DNS from the perspective of what we see outside, the analytics that we run, the algorithms that we run across those data sets, that we can actually predict, that we actually pick up things happening before they happen, right? The other thing you'll see is, now, any sort of domain that's live on the internet is, you'll see the pattern becomes very much like a wave. Now, from a weekly perspective, I'm coming into the office, there's an extreme amount of data, I go home, it drops. It goes up and it drops. And it goes over the same thing over, a week and as well as a month. But when you start to see this type of sort of data, especially on a domain that's supposed to be live on the internet, that's questionable, because I'm seeing absolutely no data, and then all of a sudden I start seeing amount of users being sent to me, and I get a spike in data which tells me there's a lot of users going towards my domain, and then all of a sudden I drop out. That's an indicator of compromise. Why am I only live for a very short period of time? The other things that you can see is the .wang domain is Chinese, right? The creator of the domain is Russian. Why? They're great friends. And then obviously you see 80 domains that he's created, and 80 domains are malicious. Do you think that if he has another 10 domains, do you think they're going to be good domains or bad domains? I can almost guarantee they're going to be bad. And then obviously the name server infrastructure that he owns, he's hosting on some that's actually malicious, so we can pretty much use that as a sort of a raise the bell. There's something wrong because the name server infrastructure he's using is malicious. And then obviously we'll tag when we first saw the malware. But here comes a cherry on the top, right? So OpenDNS doesn't just look at what's out there from an algorithm perspective. We write our own algorithms. And one of the algorithms that we wrote is called the Co-Occurrence. Now, it's going to sound weird because it's really mind-boggling, but has anyone ever done Shazam? Starts picking up little patterns and it goes, there's your song, go and buy it. So it's accurate enough to say I'm pinpointing a couple of things that tells me that that belongs to that album, right? We kind of do the same thing. We look at indicators of compromise, patterns, and we start putting that together. We go, well, that's your song. That's Lockie. And that Lockie belongs to this, this actor, and this is how many domains he owns, and this is what he's doing. Now, one of the things that we do as part of that analytics is what we call a co-occurrence, and it's written specifically by us, and it can be something as benign as I send 10 users to Cisco.com. At the same time, statistically across the world, 10 other users are going to GoogleAnalytics.com. So that means Google is just checking how popular my domain is. But what if I have 100 users going to X.com and 1,000 other users going to X.com as well as Y.com? They don't have an association. They're in different parts of the world, but the requests are going exactly the same. There's a pattern here. Something's wrong. They are associated in one way or another. And that's when we pick up the pattern. And this is how we put this together, right? So .jp is Japanese, right? So this Japanese website, I do not want you to go there, so please do not go to that domain. You might be able to buy a great bottle of wine at a very high price, but you will walk away with a payload with thanks from Lockie, I own your data now. Because this is the exploited site that gets the exploit kit dropped. Again, then gets redirected to malware install.wang behind the scenes because I already got the exploit kit. I'm doing that command and control back out via DNS, and now I get redirected to malware and I get the payload dropped, and then you get the page saying, please come and pay me that amount of money. Okay? So all those keys that I've reflected, number one, everyone else saw it a couple of days before us. Number two, there's all of a sudden a raise in the amount of what everyone else is seeing because they're already seeing it after the attack has started. Okay? And finally, let's look at how many domains he owns that's malicious. And then obviously, like I've reiterated, the actual when Ransomware Tracker saw it. So this is what a co-occurrence looks like. So you've got a number of domains. The main malicious domain is sitting in the center, and the amount of requests statistically going to both domains C and D are possible malicious domains, and we can almost definitely associate that domains are part of the same attack. So great story to tell. So if you ever see this domain, please run for your life, because that's the domain that leaves that taste in your mouth of bad wine with lots of lock here on it. Now, this is really interesting. So we can tell you how much data we can see. We can tell you the algorithm we use. But one of our PhDs, when he was writing his PhD, he wanted to take the data set that we were gaining and actually build a picture of how an attack actually happens. Now, when you look at this, it looks very colorful and pretty. But this is basically what that attack looks like from a graphical perspective. Okay? The first thing you're going to see is all the red stuff. Now, it's not red because I want it to look pretty. It's red because there's an association with all those different domains that are all working together to actually do that exploit on any sort of device that goes out there. The color of yellow is essentially, I've highlighted those colors in yellow for hashes, hashes being the malicious payloads that are associated with domains that are sort of doing those payload drops, so any domains that they own. The green, obviously, is the innocents that are sitting in between that, and we all know that we all on the internet, we might have great domains that are legitimate, but there's also a lot of bad domains that are sitting out there. So you're always going to have, different people that are in between that whole rubbish. And then you've obviously got the email address of the user that actually created those domains. So now we can build a picture. So we've got the creator of the domain. He's associated his name servers across that infrastructure there. All the domains that he's got highlighted in red are all owned by him, right? Those 80 domains that we were talking about. And they all talk to each other behind the scenes, because you've got the exploit kit already running on your device. It's already owned. And we can actually start pulling the picture together to show you that all these domains are all hosting, in one form or another, a specific payload. Now, if you remember right at the beginning of the presentation, I said the attackers run it like a business. If one payload doesn't work on your machine, then I'll have to try another and another. And I'm certainly not going to hide on the same domain. I'm going to hide it in different domains so that when that redirect happens, it doesn't become suspicious. So therefore, a firewall or any sort of DNS sinkholing that you're trying to do, you cannot actually pinpoint which exact domain is where the compromise is going to happen. Because it can happen on any of those domains that he owns, because he's got lots and lots of payloads across those domains that he can send you to. So it becomes very clear around the picture around how the attack works, so we can actually see how everything works together, how everything's interconnected, and understanding how it all flows. So like I mentioned before, in summary, domains in red are obviously everything that's blocked by us. These are the domains that are co-occurring. Like I said, statistically, the number of requests going to one domain is going to the other domain. And that's obviously showing you there from the previous slide. We can see the servers that are associated with all his domains that he owns from the 80 domains. And then they're all sharing the same name server infrastructure, so they're all associated to the same attacker, actor that's trying to do this attack. And there's the hashes and the malicious IPs that he can use as part of the redirects. So current malware distribution point, we expose the attacker's infrastructure. Like I've said before, they cannot hide without showing themselves. So they have to hide in plain sight. So when we can see the name servers, we can see the ASNs they're hosting, and we can see the IPs they're hosting. So we see everything that's happening just by understanding how the patterns work on the internet. And then we can tell you when in future there will be other malware distribution points for any sort of attack he wants to use in future, right? Now, obviously, I love using this slide because we always want to say, we saw it before anyone else saw it. And that's great, because you definitely want to prove that your solution will protect your users and will see things before they happen. So our solutions are obviously using different points that we can actually provide that protection. So obviously, if that particular user had pointed the DNS to us, got an email, clicked on that link, we would have seen where it was trying to get to, we would have blocked it. We would have blocked because we understand where that exploit kit is trying to get to. We understand the malicious infrastructure that they host out there, because we see the full visibility across all 500 different service providers we appear with on the Internet Exchange Point, as well as all the content delivery networks that we exchange with as well. So we're looking at both the caching as well as the exchanges between all the different things that are being done out there. We understand from that how the BGP puts the IP, the ASN in relationship to the way he moves between different points of the world. And then one of the interesting things is we can also tell you the different personalities of a domain. And I know it sounds really weird, but each personality acts in a different way. So the poor sod that actually has the exploit kit on his domain that he's not aware that it's been exploited, that's one personality that will always stay constant, apart from when that domain gets cleaned out and they find another victim, right? The personality in between that is different personalities from a payload perspective. So I'm trying this version of lock here, I'm trying this version of lock here, I'm trying this version of Tesla crypt until I get something that I can lock you down with. So they're called droppers, right? And then you got the new one in the whole game is which domain is now taking the payment. So please pay me in Bitcoin. So this is the domain that will be the payment site. And then what the attacker does, he's not only changing how often his IPs are moving across where he's hosting across the different points of the internet across the world, across the different domains that we're seeing, but also at the end of the day, how those domains act, whether one's being a dropper at one point or one's being the actual payment site, and obviously the different exploited domains that he's got out there that he's using to do that exploit run. So how do we predict everything before it happens? Obviously, we see over 90 billion requests a day. We obviously analyze it with all different types of analytics, our own algorithms, machine learning, because no human can react as quick as that. And we obviously can predictably determine when domains will be part of a specific attack just by all the indicators of compromise and all the different data points that we have from a specific user. We obviously got huge amount of data lakes that we look through. Obviously that's going to grow with the integration with the bigger Cisco around Telos. Telos having endpoint, email, web, malware, IPS, etc., global footprint. Most of the internet's built on Cisco gear. We can see a lot of all the other indicators that can reinforce or give us new alerts to other things that might be being done internally within a network that can be reported up to us from different devices. And just starting from a single point of information, we can pivot between different data points until we can build a picture between what we're seeing is an actual attack and when it will initiate a different attack, and how often he will try those different attacks in time. I have a particular actor that's been running for the 6 months of this year, where he is consistently changing the number of domains he's using. So at some stages he's using 400 domains, some stages he's using only about 60 domains, and he changes his behavior over time. And that's just based on how he's going to try and get as many victims to be compromised by us, by his attacks at any point in time, so we can see that. So our traffic is not static, it's not point in time. We are continuously analyzing the data, we are continuously looking for those type of different pivot points that we can look at to see that something is malicious, so that we can catch it before it starts hitting the rest of the world. And that's fundamentally one of the key things, is to be really fast, but also really accurate, right? And to have something that's very transparent to the user without him actually knowing, like you guys didn't pick up that we were protecting the infrastructure for the whole event that's been happening. So obviously we all know that the internet is not unlimited, so there's obviously more zones that are prone to be exploited by criminals. I usually pick on the Russians, unfortunately, because a lot of the domains that we see are coming from Russia, China, and those type of areas. So there is a lot of areas that you get that are more prevalent around the attacks itself. Now I'm going to switch over to demo to show you some of the things that we've done over the last couple of days. Okay, so I'm just going to refresh this and skip out of. Okay. There we go. So, this is a refresh. So, I'm going to show you just very quickly the dashboard for this particular event. So, we are seeing, there we go. So, over the last, I would say, a couple of hours, I would say mostly to 8 hours, we were blocking a lot of the content that people were trying to get to, and obviously domains that were malicious in intent, so we wouldn't allow you to resolve to those domains. But somewhere along the night yesterday, I think during one of the hackathons, people asked us to stop blocking, so we did. But essentially, while we were blocking, over the last couple of hours, we blocked about 289 requests coming from this network that you guys have been on. Okay? We've picked up on 5 different botnet requests, and we can give you a graph of when we saw the peak of traffic to the times that it's dropped in traffic. So a lot of you guys actually probably maybe started to go home around 4 o'clock in the morning. Does that sound right? Yeah? We can also tell you what are the top domains that we've seen over the event. And obviously the network that we're seeing is just what's coming from that public address range. So all of you guys are being natted behind a public address range or a group of IP addresses, and that's where we're seeing you coming from. Now, let's get a little bit more interesting around this. So, I'm just going to show you quickly some reporting here. So, security activity. So, as we are not blocking anymore, we are telling you everything that's going out there and we're categorizing it. So, for anyone that's pointed their DNS to us and is applying this policy to categorize what they're seeing, this is where we're seeing the activity, and it's all live at this point in time. We can also tell you other things like, for example, and this is a kind of a prime one, everything uses DNS, including those Fitbits that you have around your wrists, including the TVs that are connected here. So we can tell you also not only the different types of Internet of Things that we're seeing, but also the type of applications you're going to. And as you can see, Facebook is really leading the page there, right? So Facebook, Slack, GitHub, does that sound pretty real? Does that sound like the top domains people are visiting? Absolutely. We can also see other things that we probably I don't even know about. Give you an example. Let's look for one. PubNub. What is PubNub? Let's see if I know anything about it. PubNub. Come on. Cloud services. Sorry, it's a little bit delayed here. So, PubNub, where did we see that? I can actually go and actually, reduce that and look at just the Internet of Things. Let's see what we've caught on the network. Okay, so we picked up a couple of requests for Samsung, Philips, Logitech, and Fitbits. We can filter that out even more and pick up on, let's see, cloud data services and content sharing. So we can pull as much information as we want, but all we can actually do at this point in time from a DNS perspective is obviously the requests that are being made to iCloud or Gmail, it's making a request to a specific domain, and that's what we're seeing, right? So one of the things that we've done recently, because Cisco's kind of a serial buyer when it comes to companies, which is great, we've bought a company called CloudLock. So what we'll be able to do is not only tell you that we're seeing things like Google Docs being used, but we can actually go and identify what exactly are you uploading to Google Docs. Are you putting any sort of sensitive information up there? Should we actually block it? Those type of things. So we can actually control the content that's being distributed out there, and that's what we're working on as an integration now. So because we want to keep to the same sort of speed and low latency type of solutions, the Cloud Block is an interesting buy because it doesn't depend on proxying. So it's not proxying everything to a cloud and then doing its investigation. Cloud Block actually has APIs into all the major different cloud vendors out there. And basically, if I want to verify what exactly someone's trying to do, it's an API call, which keeps that speed. And you guys all know how quick APIs are, right? So the only time that we would actually proxy anything, and I've already had an example with one of the guys that created a domain during the last 24 hours, is that if there's new domains that have come up on the internet, we have no intelligence around what they're doing. They're brand new, okay? So we can't tell you they're good, we can't tell you they're bad, because they haven't done anything to start picking up on that behavior. So what we do is we actually by default block because we're not sure. And that's not a block that's done leniently. We're looking at different intelligence that we pipe into, and we're looking at and we're going, do you know about this? No one else knows about it, it's brand new. So we'll block until we've got some sort of intelligence that tells us, allow it to happen. And that's the same for anything that's gray. Gray domains are domains that we don't know whether they're malicious, but we also don't know whether they're benign, right? So that's, in those type of situations, you can choose to proxy, and that means we'll go and proxy and look down the stack to see, is there anything that can tell us that that domain is going to have indicators of compromise that we need to block. So that's one of the key things. We want to be fast, we want to be accurate, and we want to apply it in any sort of layer that goes down the stack. So we're very much driven around defense in depth methodologies, going in a step-by-step method. Other things that you can see that we can pick up on is, and you can pull on these reports, is what are the total requests. Like I've mentioned before, we wanted to see what is the DNS baseline. And as you can see, it's quite an interesting one because it's only been over 24 hours, but you can see essentially when everyone went to bed and when things started happening once again. So that's pretty good to see. And for some reason, people only started arriving at 9 o'clock rather than earlier than that, so we can see exactly what they're doing. We can also tell you what are the top domains. So this is going to be quite interesting because I'm not content filtering anymore, so there might be some interesting domains that can be seen here. So is there anything that tells me? I saw an interesting one yesterday. I wish I could find it now. I could only deduce that it wasn't something we wanted to actually go to. I'm not seeing it anymore. Maybe over 24 hours I might be able to pull more reports. But I can basically go and select how, it's not been 7 days, but I can pull as much information to see what else I can find that people are going to. And we can actually categorize it down. So it looks like there's a couple of key winners here, but it looks like Google seems to be the key one, and Facebook that I can see, and Slack, obviously. And we can tell you what are the top categories we've seen, right? And this is now not blocking anymore. This is based on what we're seeing. And you're all good guys because most of the requests are going to software and technology companies. And I'm not seeing any porn there, so it looks all good to me. Oh, there is porn. 939 requests. With the bad actors, please stand up. So there's a lot of things that we can see from, from having in line. Obviously, we're not blocking, which is always great. But I guess one of the things I always like to do, and I think we've got a little bit of time, is we can search on anything, whether it's a domain, a URL, ASN, hash, email address, and this all contributes to different things. So if I'm dealing with an incident and I pick up on a hash that's going through one of my endpoints, I can go investigate that hash. If I can't find anything here, then I know I need to sandbox, because that means no one else knows, because I'm querying not just what I know, but what ThreatGrid has, as well as what Talos has from a holistic point of view. So is there any domains you guys want me to do a quick look up on? How about this one? So, bigcolo.com sounds very legitimate, and it is. But one of the key things I can show you here is Big Cola obviously distributes soft drinks, but here is one of the key indicators. Look at how often it's used. It probably wasn't used as often before, and then you get an incline in data, and then a drop and an incline in data. But here comes the really sexy part, right? Pick any payload. This is the payloads that I'm seeing coming from this domain. Let's pick randomly any payload that I want to pick on. I will pick that one over there. What is it telling you? We've got test script 3.1, okay? Let's run this again. He's got a number of different hashes. I'm going to flick through one and just pick one randomly. Test script 3.1 again. Right? So what's happened here is they've got a domain that they've exploited. They've dropped every variant of 3.1 onto this per domain, and they basically a reservoir for anyone who needs to go and fetch payloads. That becomes very malicious for us because, as you can see, no one really uses this domain apart from when they have to go and fetch any sort of data, and that's when you start, or any sort of payloads, and that's when you start seeing more data being flown onto that. Plus, it's hiding behind a very normal looking domain that sells soft drinks. So these are kind of the things that we're working with. We see some really nasty stuff out there. One of my colleagues actually cracked a joke. He came across a .onion domain, and you all know what that means from a dark web perspective. And we can mine that data. We can mine through that data and then start drawing a picture of what we see. So what are the associations with what he's talking to? He basically stated that he wouldn't share that information with us because he couldn't sleep that night, and he crawled up in a fetal position and started crying. So we see a lot of the stuff that is just out there that can be picked up in pure sight. So another thing I wanted to just show you quickly, I've mined at a point in time, and I'm going to reiterate, this is using the APIs. So I use the APIs, I use Open Graffiti, which is on GitHub. Anyone who wants to run their data sets against Open Graffiti can go and look it up on GitHub. Essentially, I ran against one of the sponsors' data set, and basically, this is basically what we see from the outside world looking at a specific domain. And then all the relationships within that domain, who it talks to, what is email, what is DNS, what is hashes, what is malicious in between those, okay? So I ran it against there we go. Can you guys take a guess of who this is? It's quite big. Anyone know who this is? It's one of our sponsors, right? So we can see every relationship that they have from the outside world looking in, right? So as you can see, I'll quickly give you a highlight of what's there. Everything that looks white to you guys but is actually meant to be pink is all of nos.pt's domains. So you can see all the different relationships of domains over here, from their cinema sites to their customer services to whatever, right? Anything that's colored in purple is their DNS providers, which I'm a little bit upset that it's not us. Okay? And then we've got all the stuff that's in yellow, which is a few odd that you see over there, is all malicious payloads that are owned by devices, by domains in the internet. All the blue is all the relationships that they have with all the different mail servers that they're talking to across the world. Okay? So we can build a pretty nice picture that we can then start, drawing up the relationship between what they see. And you can also do things like this, which is always great to run in the background when you go and see someone, because they'll always go, wow, that looks great. What is it? Well, that there is our domain, and that's all the relationships that we know about it. And don't worry about the yellow stuff. It's all good. All right? Obviously, if it's worse if it's red, because then you know that there's some really interesting stuff there. But we can essentially build a picture around what's going on to any sort of domain that we want to build a picture on, right? And it gives us a pretty good idea of how things are constructed, how the relationships are working, who they talk to, who they don't talk to. And, you can build a really nice picture. And you can also see some of the strange domains. So if I spent more time, I might go looking for, certain domain extensions like the .reus, the Soviet Union's, the .su's, which is still alive, believe it or not, and Chinese domains, and start highlighting those, saying, do you guys actually talk to these domains? And we can build relationships around that. Any questions, guys? Was that interesting? Yes?
How do you do when you have a green domain and then it gets malicious for anyway?
So we can pick up a domain being, by reputation, being benign, or we can start picking up when certain actions start happening, like there's more interaction of users going to there. We can start seeing that users are then trying to call out from your domain to other domains. So we start dynamically picking this up. So we start raising the alarm bells. We start raising the score, because we score you, right? We take all those indicators of compromise that I've spoken about, and we attribute that into a score, and we apply that. And we'll say, I will resolve or I won't resolve. Or I'll warn that this is raising the bells, but I might not block it straight away because there's nothing really telling me that you're fully malicious. So if your domain starts changing its behavior, we will start noticing it, because we start seeing how all the attributes of users are using going towards that specific domain. And it's always dynamic, which is key to fighting the fight.
Who has access to that?
To this?
Yes.
Okay, so here's the trick. Open Graffiti's on GitHub, so you can use it. The data set is at a price.
It's a product that you sell.
We don't sell it. It's Open Graffiti is anyone can use Open Graffiti and run their data sets against it. Mm-hmm. The intelligence, which is the data set, is where we sell it as a product to people like incident responders, people who have large intelligence centers with big data lakes where they're pulling all different sources of intelligence, and they use this as another attribute to pull on. And it effectively helps a lot because we've got relationship with other vendors. We're not vendor agnostic. So we have relationship with Checkpoint and FireEye and those type of organizations, because they might say to us, I'm seeing these domains, can you tell me more? I can tell you more about A, B, and C, but I haven't seen this one. And we exchange that sort of data to build on a reputation score for that user. So, but yeah, Open Graffiti is there, but the data set is obviously a product.
Hi. In my devices, I run a custom hosts file to block some host names. It's an ad blocking strategy, but I think it works the same concept as your system. But I'm seeing that it's not as effective as it once was, because a lot of ads that were showing on the internet and a lot of phishing sites are appearing as an IP address instead of a host name directly on the page. What can be done in that situation?
No, we actually we don't just block on URLs or domains. So our intelligence is beyond that. So we can see, because of what we see from an IP perspective, so where they're hosting those IPs, the reputation of the IPs is also marked against. So how we protect and enforce, people trying to call out to IPs, is to do an enforcement by an actual agent that runs on the device. So and that's dynamic too, and that's why we need that agent on the device. So we are constantly updating those IPs on that list to say, if you're trying to resolve to an IP, the roaming agent needs to block it. So we're not just blocking on just URLs and domains. No, definitely not. We would be useless then. Any other questions? Well, guys, obviously this is the enterprise that I've been showing you. I mean, you guys can go to opendns.com. You can get a free account. You can take and point your DNS resolution to us. We will resolve the DNS for you, and you can use our product and play around with it. And if there's any interest, we can also, give you sort of concepts. We can go and run it for a while and see what you see against the APIs or whatever the case may be. Okay, thank you.